Hello students, we'll discuss how to display the nodes present in the single linked list. Now, displaying nodes is nothing but displaying data items which are present in the node. For that, we have to traverse the linked list from the very first node up to the last node. While traversing, we'll visit the node and we will print the value present in that node. Okay, so for that we will first of all assign the head node or value of head node to one pointer variable like a trav. So now trav is pointing towards very first node, as well as head is also pointing towards the same node. So this is what the initial situation. Then in the next statement we will have a loop while trav is not equal to null. Ultimately this condition will check whether we reach at the end of the linked list. Okay, so if not, then we will print the trav arrow data. Ultimately at the very first iteration it will print the value 5, then set trav is equal to trav arrow next. So trav arrow next means this field, so value of this field is nothing but address of the second node, that is this node. So the value of second node is now assigned to the trav. So now trav will point towards the second node. Okay, then it will print trav arrow data. Again say trav is equal to trav arrow next. So trav arrow next is now this. So trav is now pointing towards third node of the linked list. Then it will print trav arrow data. So after 5, 6, and then it will print the 7, and trav is equal to trav arrow next. Now trav arrow next is nothing but the null. So while trav is not equal to null, now this condition does not satisfy, so our while loop stop and it comes out of this while loop. So this is a way in which we can traverse the linked list, and while traversing we are printing the data items which are in the linked list using this particular statement, that is print node contains value is equal to trav arrow data. And for traversing we are just doing this trav is equal to trav arrow next. So same logic can be used in multiple times. Consider one more example like counting nodes in the single linked list. Now for that we use a get count method or get count algorithm. Now the get count algorithm is also called size, or sometime you will get this size method. So both are doing the same thing. They will scan or traverse the linked list, and while traversing or scanning the linked list they are just counting the total number of nodes present in the linked list. So initially we are assigning the address of first node to the trav pointer, that is the traverse pointer, then assign the value 0 to the counter variable and do something till the trav become null. And do something means we have to increment the counter variable as well as move towards the next node, that is nothing but traverse the linked list. So the statement number 5 is used to traverse the linked list, and statement number 4 is used to increment the counter. Ultimately at the end of the loop, or whenever the loop get terminated, we are just returning this CNT, that is nothing but the counter, which gives total number of nodes present in the linked list. So again same thing, we are traversing the linked list. At each and every traverse we are incrementing the value of CNT. Okay, so this is another application of traversing a linked list and printing the total number of nodes present in the linked list. Now the next thing is nothing but sorting of single linked list. Now sorting of linked list means we are just arranging the values or data items present in the linked list in ascending or descending order as per the user requirement. For that we can use multiple ways. For example, one can use bubble sort technique, one can use selection, quick sort, or any other sorting method. Ultimately, the sorting method is applied on the data items which are present in each and every node, but it will not change the address of the nodes. Okay, now we are in this case we are using the bubble sort. The main steps which are involved in the bubble sort are nothing but compare the first and second node, that is nothing but compare the consecutive node at each and every iteration, but at the initial state it will compare first and second node. If both these nodes are out of order, that is the left node or the first node is greater than the second, then swap them. If they are in order, do nothing is the statement. Now if both are out of order, swap them, go for the next, that is second and third node, check whether they are in the order or not, then go for the next, that is third and fourth, then fourth and fifth, and so on up to the end of the linked list. Ultimately at the end of first pass we are making n-1 comparisons. Okay, and at the end of the first pass the greatest node or the value of greatest data item is present at the last node. Then in the next pass we are doing n-2 comparison and the second most greatest value is present in the second last node, and so on. So this particular step, that is step number 1, 2, then 3 will get repeated until all the nodes in the linked list get sorted. Consider this is the sorting algorithm. As we know, we are not moving the head pointer, so we are creating sort head another pointer, and trav is initially assigned to null and sort head is assigned to head. Now while sort head arrow next is not equal to null, we are doing something in that. First of all, we are assigning the value of sort head arrow next to the, so now the situation is something like this: head and sort head pointing towards very first node, something like this, and trav is pointing towards the second node. Okay, then while trav is not equal to null, we are comparing trav arrow data with sort head arrow data, that is 16 is compared with the 4. Now in this case 4 is smaller than 16, ultimately both are out of order and hence we are going to swap them. Okay, so this is what we have written here. Ultimately 4 goes to the first position, 16 goes to the second position. So for that we are creating one variable temp in which trav arrow data is assigned. Then trav arrow data is equal to sort head arrow data, and sort head arrow data is equal to temp. So this will gives the new value to the first and to the second node. Okay, so this is something like this. Now trav is pointing towards the second. Then after this trav will be moved towards the next, that it will points to the 7, then 7 will be compared with the 4, then it point towards the 25 and so on. Okay, so every time if you observe, every time we are just moving the trav first and comparing the trav with the sort head arrow data. So this is internal loop which will just compare the first element with the second, then first with the third and so on. If required, swapping will be done. At the end of this while loop, the highest value is present at the last node, and then we are moving the sort head to the next. That is, in the second pass, the sort head will point towards the second node, and we will start our sorting from the second node and onward till the end of the linked list. So this is how the sorting of single linked list is done. Again, we are using the technique of traversing the linked list, comparing the values, and if they are out of order, then swap the values and do the things repeatedly. Now you have two assignments. First one, where you have to search a value inside the single linked list, and second, where you have to reverse the given linked list. For a reversing linked list, you can use different functions which we have discussed. The functions which we have already discussed are insert first, insert last, insert at, delete first, delete last, or delete at. So using these 6 functions, you can write the second algorithm. Thank you.